So now that we talked about two different measures of center, the median and the mode, or the median and the mean, let's now talk about the differences between the two and when one might be preferred over the other. So let's say you have a very simple data set, just the numbers 1, 2, and 3. Let's say you wanted to find the median, what was it? Just 2. Numbers are already sorted, number in the middle positions, 2. What about the mean?
Also,
Yeah, if you added up all the numbers, divide by 3, you'll see that 6 divided by 3, which is also 2. Okay, so let's say that what we do now is we add a number that we call an outlier, which is a number that's very different from the existing numbers. So let's say that we add a number that's much larger than the existing numbers, let's say 100. So what would the new median be?
2.5?
Yeah, so the average between these two numbers on the sides of the midpoint, so that would be 2.5. What would the new mean be? So 126 divided by 4, whatever that is.
26 point something.
Yeah, so 26 point something. I think it's 26.5. Okay, so let's say that that's what it is. So adding this new outlier here, we only added one number. Which measure of center changed more, the mean or the median? Yeah, the mean changed a lot more than the median. The median was relatively stable. So we say that the mean is susceptible to outliers. And in contrast, we said that the median is resistant to outliers. So which of these properties do you think is more desirable, being susceptible to outliers or resistant to outliers, if we have a measure of center?
Resistant?
Yeah, just because of how these words are phrased, the word susceptible is weak and it's worse than the word resistant. So just because of how this is phrased, you can imagine that being resistant to outliers is better than being susceptible to outliers. So because of that, we might think that the median is better than the mean. And actually, in most cases, it is, because of this property of being resistant to outliers. That said, moving forward in this class, and in statistics in general, every time we're trying to measure the center, we're going to use the mean. And so that might seem like it's a contradiction, which is, why would we use the mean, which is susceptible to outliers, when we just said that the being resistant to outliers is more preferred? Any hunches, any ideas? So moving forward in statistics, why does statistics use the mean as a measure of center, as opposed to the mean?
If there are no outliers, you can do more exact, answer, more, a better answer for the typical value.
Okay, that's a good guess. So maybe in real life there are no outliers and we don't have to worry about them. But it turns out that in real life there are outliers. So you always have a data set where you have values that are considered outliers that are not typical for that data set, that are either numbers that are too high compared to the rest of the numbers, or too low. And so anybody want to add to that?
I'd say that they usually remove the outliers from the data set before for calculating the mean.
Okay, that's a good suggestion. So the other suggestion is outliers are always removed. But then if you start cherry picking numbers that you're going to remove, that kind of introduces its own problem. Where how do you know that the numbers you're cherry picking are the numbers you should be removing? What if you're removing numbers you shouldn't be removing? Yeah.
The median kind of disregards the outliers, but in statistics, like the outliers mean just as much as the other ones.
Yeah. So it's in real data sets and statistics, outliers are important because they're going to be there. And so usually they're there either because of measurement error, because the researchers made a mistake measuring, either their equipment made a mistake or they made a mistake, or even if they didn't make a mistake measuring, it could be that those values in themselves are just supposed to be there, but they're just not typical of the other values. You may have different weights where somebody just happens to weigh a lot more than everybody else, or you can have weights where somebody just weighs a lot less than everybody else, and that's not because of measurement error, it's just because that's how it is. And so we want to preserve the values where it's not because of measurement error, and we want to preserve those, and we want to make sure that they're accounted for. And so it turns out that there are a couple important reasons why people continue to use the mean, and they're really they may not be for the reasons you expect. So the first reason is that statistics has been around for a long time, longer than calculators or computers have been around for. And of these two calculations, the median or the mean, which one do you think is easier to calculate? So imagine a large data set with a lot of values. If you were to calculate the mean versus the median, which one would be easier to calculate? Yeah.
The median?
Yeah, why do you think the median?
Because once you have your data set organized, all you have to do is find the center.
Yeah, but then that's a big if, right? You have to organize the data first. So is that a cumbersome thing to do, organizing the data set? Yeah, it turns out that if you were to try to find the median, you'd have to organize and sort all your numbers first so that you can pick the number that's actually in the null position. And it turns out that sorting your data set is actually very tedious. It actually takes a long time. And so because of that, it turns out that calculating the mean is a lot easier because you're just adding two numbers at a time. Just adding the first two numbers, whatever that is, add the third number. Whatever that is, add the fourth number. So you're just adding two things at a time. And that actually turns out to be faster and easier than having to sort a lot of numbers first. And because of that, because of historical reasons, people have traditionally used the mean as the measure of center. Despite the fact that it's susceptible to outliers and it has that undesirable quality. So, okay, maybe that was done in the past, but now you might be thinking, oh, this is 2024, and we have calculators, and we have computers, and we have ChatGPT and all of that. So, now that we recognize that the mean has this undesirable quality of being susceptible to outliers, why don't we change statistics and rebuild statistics so that every time we want to calculate the center, we use the median instead? Why don't we just redo that framework of statistics? Yeah.
It would be going back to the situation of the outliers, we'd be completely beriting the importance of them.
Yeah, maybe, so now we're choosing a measure of center that is resistant to outliers. And, but maybe, so that's something that will, that's arguable, right? Maybe we do want to be resistant to outliers. We're not ignoring them completely, we're just not allowing a single number or a couple single numbers to completely change the center. So maybe that's what we want, yeah.
Further calculations and further progress of statistics was based off of the mean, so you would have to redo a lot of those, or I guess re-engineer all of the calculations that were made.
Yeah, statistics, just like any other math class, is built, one thing is built on top of the other thing. And so if we do one thing, we're gonna have to re-engineer the entire thing. So that's one thing. And so, it's kinda like, the keyboard, right, the QWERTY keyboard. It seems like it's arbitrary, but there was an initial reason for that. And you guys happen to know why there's this keyboard that's in that particular, schema? Yeah.
Because people could type too fast when it was A, B, C, D, and it would just like break the keyboard.
Okay, that's one reason. Any other reasons, Jeff?
It's because it's built off of the old layout of typewriters, wherein they would type too fast. If it was organized a different way, actually, was it? It was based off typewriters for some reason.
Yeah, very good. So it was based off typewriters back in the day when typewriters had these mechanical arms that would come out. Every time you press a key, an arm would come out, and there was ink attached to the end of the arm with that character. And so back in the day, people, the typewriter arms would often get stuck together. If you had words typed out that had two letters that were close together, the typewriter arms would actually get stuck together. So people had to lay out that keyboard and pick letters to put on that keyboard so that the letters would not co-occur often in actual letters in real life. So that's why in words in real life, you don't have the letters Q and W often occurring in words together. So that's why on a keyboard now you have the letters Q and W occurring together. So the point is that was done initially because back in the day you had keyboards with mechanical arms with ink on them. But nowadays you don't have that. You have electronic keyboards, and you don't have mechanical arms. So why don't you think that why don't you just go back and change it so that you don't have this issue of arms being stuck together? So why don't you just change it so it's something that makes sense, like A, B, C, D in alphabetical order? Yeah.
Because the early school curriculums, when they were switching from typewriters over to early computers, a lot of that curriculum knowledge would be lost between schools, and also lost from people converting from typewriter to computer, and would be too much of a hassle as ordained by the curriculum coordinators.
Yeah, very good. So changing it is not a technical issue so much as it's a human issue. So it would actually affect an entire generation of people. People who are used to typing quickly with the QWERTY layout would now fail for an entire generation. So you would mess up an entire generation of people before it got better. So that's kind of the reason why this is the same thing, is that admittedly the median might be a better measure of center, but we don't want to re-engineer that entire framework if it's good enough as it is. So any comments so far? Okay, and so secondly, the more important issue is that right now you should feel uneasy because we're just accepting something because it's good enough. But to add to that, it turns out that this issue of outliers only matters if the data set is really small. So the data set is really small, like in this example, there's only 3 numbers. You add in one outlier, then yeah, it's gonna shift the measure of center a lot if it's the mean. But if you have a lot of data points, 1 million or 1 billion data points, then it turns out that any outlier you have usually has another outlier that is in the opposite direction that undoes it. So, for example, if you have 1 million people's weights, you might have an outlier of a person who weighs a lot, like 700 pounds, but then you're gonna have other outliers that are very small, and essentially, whichever measure of center you use, they're gonna, the 2 outliers in the extreme directions will undo each other. So usually when you have very large data sets, then this issue of outliers usually doesn't matter so much because the extreme values undo themselves. Any questions? Alright. And the reason why I bring this up is because usually in your own applications, sometimes you won't have massive data sets. You'll have smallish data sets, hundreds of values, for example. And in those cases, even though in statistics, you'll be used to seeing the mean used as a measure of center over and over, if you need to use a measure of center in your own application, then you should feel free to use the one that makes more sense to you. So if you want your data to be resistant to outliers, which in most cases, that's what we want, then you should use the mean. But moving forward, you'll see the mean used over and over as the measure of center. Any questions? Okay. So the mean and the median are measures of center that people often use.